I'm Nova.
I'm Alloy, and this is AgentStack Daily.
Hermes just cut cold start time from about 4.3 seconds to roughly 0.9. That's the kind of improvement you feel before you've had time to complain. NVIDIA, meanwhile, has introduced Cosmos 3 Edge for robotics and physical AI, and Unity developers can now let an assistant manage assets, control scenes, and edit scripts directly inside the editor.
Okay, that's a lot of movement towards software that acts where the work happens. People are building agents that stay open beside an editor all afternoon, coding assistants that remember an entire repository between sessions, and local work agents that preserve context without sending everything through a remote service. The tools aren't just getting faster. They're moving closer to the code, data, applications, and machines people actually operate.
Today, Hermes 7.20 and the terminal-based AI coding agent Claude Code .206 lead the releases. NVIDIA pushes world models toward edge hardware, and the EU starts enforcing new AI transparency duties on August 2nd. You'll hear about a 27 billion parameter ternary model, persistent codebase memory, long-running agent failures, and two increasingly popular bridges into Code and Unity. Hermes Agent shipped 7.20 on July 20th as the Quicksilver release, and the headline is speed. The startup screen previously consumed about 4.3 seconds before a first turn reached the model. Nous research says that now takes roughly 0.9 seconds, an improvement of around 80% across the terminal interface, gateway, text interface, desktop app, and scheduled jobs. Reasoning models also stream their thinking by default, while responses paint token by token instead of waiting for a complete line. The same build underpins .206 of the terminal-based AI coding agent Claude Code. Hermes carries the documented capability changes here.
For seconds sounds small until it taxes every interaction. Then it becomes the software equivalent of a door that sticks. The desktop work went well beyond startup. More than 20 performance changes reduced the Markdown splitter's CPU cost on long responses by a factor of 14, virtualized large diffs so the review pane doesn't freeze, and stopped session switching from repeatedly recalculating the layout. Streaming no longer forces the sidebar and every tool row to render again on each token. Backends begin warming when hover behavior suggests you're about to use them, and hidden panes wait until idle rather than joining the startup stampede.
There are meaningful workflow changes too. Hermes can manage a Now subscription from the terminal, connect directly to Bitwarden and 1Password for credentials, show subagents working live, and let smart approvals judge flagged commands by default. A durable delivery ledger preserves a completed answer through a gateway crash. That's less flashy than token streaming, but losing a finished result because the transport fell over is precisely the kind of bug that makes an agent feel untrustworthy. The text interface now renders Markdown incrementally as well, so long answers become readable while they're still arriving.
I like the speed story, but I don't buy speed as a substitute for reliability. The release folds in the earlier infrastructure patches, and news points to roughly 3,300 closed issues and 2,245 commits. Those numbers show activity, not proof that sustained sessions are solid. Still, the combination is compelling. Near-instant startup, live reasoning, faster desktop rendering, integrated secrets, and responses that survive gateway trouble. Hermes is making a credible bid to remain open next to an editor instead of being launched for one prompt and dismissed. The next judgment comes from weeks of continuous use, where session handoffs and long-running workloads expose whether Quicksilver is merely quick or genuinely durable. A 27 billion parameter model on a consumer laptop? Okay, that gets my attention. PrismML's Ternary Bonsai 27B appeared on Hugging Face on July 4th as a gguf file, the disk-friendly format commonly loaded by llama.cpp for local inference. Its weights are ternary, meaning each weight is represented by one of only 3 values. The listing also carries a 2-bit tag. That radically shrinks storage compared with an ordinary 27 billion parameter checkpoint.
And it isn't hiding in a dusty corner of the catalog. The repository has passed 432,000 downloads and 876 likes. Its tags indicate support for CUDA on NVIDIA GPUs and Metal on Apple Silicon. Packaging matters here. GGUF lets existing local model software load the checkpoint without a bespoke serving stack. That opens the door to private chat, offline assistance, and local agents on machines that normally couldn't hold a model in this size class. Have you ever wanted a larger local model but bounced off the memory requirement? That's exactly the wall this format and compression scheme are trying to lower.
The exciting part isn't 2 bits by itself, it's what stays intact after squeezing the model that hard. A 27 billion parameter label can suggest substantial capability, but aggressive quantization can degrade language quality, instruction following, and factual consistency. Download counts tell us people are curious. They don't tell us the compressed model behaves like an uncompressed 27B system.
Exactly. Consumer laptop territory is plausible, frontier quality isn't established. Still, Ternary bonsai shows why local inference keeps moving. Model architecture, weight representation, and standardized packaging can matter as much as raw parameter count. A model that fits and runs privately may be more useful than a stronger one that requires a remote API, especially for sensitive documents, intermittent connectivity, or predictable local costs. The community response will reveal whether this is a durable local agent component or a very popular compression demonstration. WADP shipped 0.121 on July 16, then continued receiving commits through July 21. The open source project lives under the Claude organization, has 4,931 GitHub stars, and describes itself as the place where data access meets operational intelligence. Translation: it wants one interface for working with data and understanding how the systems behind that data are behaving.
That sounds almost suspiciously sensible. Teams commonly use one application for database queries and schemas, another for metrics, another for logs, and something else for connection pressure. Then a slow query turns into 4 browser tabs and a small identity crisis. HUB's pitch is that data access and operational context belong close enough together that a person can move from "what did this query return" to "why did it slow down," without rebuilding the situation across separate tools.
The repository's activity is encouraging, although the exact depth matters more than the tagline. A release on July 16 followed by fresh pushes 5 days later suggests active development rather than a quarterly code dump. Nearly 5,000 stars also gives the maintainers a meaningful user and contributor feedback loop. It doesn't prove production readiness, but projects without a giant vendor can earn useful scrutiny at that scale.
The open question is which databases and operational signals are truly connected. One surface could mean a deep link between queries, latency, errors, and resource pressure, or it could mean several adjacent views under one roof. Those are very different products. Even so, consolidation has real value for small infrastructure teams that can't maintain a sprawling observability estate. If HUB can connect a query to the conditions surrounding it, rather than merely placing database and monitoring screens beside each other, 0.121 sits in an attractive lane, self-hosted tooling that reduces tool sprawl without hiding the underlying systems. This one attacks a genuinely annoying problem. Coding agents forget the repository whenever their usable context disappears. Data's codebase memory-mcp, which shipped 0.9 on July 8, turns a source tree into a persistent knowledge graph. That's a structured map of files, symbols, and relationships that an assistant can query repeatedly instead of rereading raw source every session.
The project makes big performance claims. It says an average repository indexes in milliseconds, queries return in under a millisecond, 158 programming languages are supported, and retrieval uses roughly 99% fewer tokens than passing raw files back to the model. Those figures come from the project, so they're claims until independent users reproduce them. The packaging is concrete, though. It ships as a single static binary with no runtime dependencies and exposes the memory through Model Context Protocol, the standard interface that lets assistants call external tools and data sources.
And if the claims hold, the everyday change is substantial. Instead of pasting files again, a coding assistant could ask which module owns payment retries, where a deprecated function is still called, or what depends on a proposed interface change. In a monorepo, those aren't cute demo questions. They're the orientation work that consumes the first chunk of every debugging or refactoring session.
The repository has reached 33,443 stars, with its latest noted commit on July 19. That's enormous attention for infrastructure that mostly sits behind the assistant. It also connects directly to the context pruning research coming later. Agents need both durable memory outside the context window and better judgment about what remains inside it. Persistent indexing doesn't make a model understand architecture perfectly, and a knowledge graph can become stale as code changes. But a local, fast, queryable map is a much better starting point than repeatedly pouring an entire repository into a prompt and hoping the important relationship survives. OLA/OS has crossed 5,500 GitHub stars with a simple promise: a local first work agent that learns your context quickly and doesn't forget it between sessions. The project was pushed again on July 20, so development is active, although the repository doesn't yet have a tagged release.
I find the continuity pitch more interesting than another list of agent tools. Most assistants behave like a talented contractor with selective amnesia. You explain the project, the naming conventions, the files that matter, and the way your team works, then a new chat opens and the relationship resets. OLA/OS wants that context to remain on the machine, close to the files and applications that produced it.
Local first also carries a privacy claim people can understand. Work context may include unfinished documents, customer material, source code, and habits that reveal how a person operates. Keeping that information locally can reduce dependence on a remote service. It doesn't automatically make the software secure. Open source isn't magic dust, but public code does let people inspect, modify, and fork the system rather than accepting a sealed cloud product.
The project now has enough attention to prove the pain is widely felt, not enough maturity to prove it can become a dependable daily workspace. Without a packaged release, it remains closer to a source-driven project than a polished product for non-technical users. Still, persistent code memory from the previous item and persistent work memory here point in the same direction. People don't just want smarter answers, they want an assistant that remembers the environment in which those answers matter. If OLA/OS can preserve continuity without becoming intrusive or brittle, it starts to look less like another chat box and more like a coworker who was present yesterday. NVIDIA putting edge on Cosmos is exciting because world models are usually heavyweight beasts. On July 20, NVIDIA published introducing Cosmos 3 Edge on Hugging Face, positioning a slimmer member of its Cosmos family for on-device runtimes, robotics, and physical AI rather than only data center scale work.
Cosmos is NVIDIA's world model line for systems that need to represent and reason about physical environments, including robots and autonomous machines. Edge implies tighter latency and hardware limits, inference near the camera, sensor, robot, or embedded computer instead of sending every input to a remote cluster. That could matter in a warehouse robot responding to changing surroundings, an autonomous system operating with uncertain connectivity, or a simulation loop where network delay ruins iteration speed.
But this introduction is still a marker, not a complete deployment specification. The accompanying model card and weight listings need to establish supported input types, output formats, target hardware, precision options, input resolution, context length, and any video sampling details. NVIDIA commonly publishes those details alongside weights, but the introductory post alone doesn't settle them. So yes, Cosmos on the robot is the compelling idea. No, we don't yet know enough to declare that any particular robot can run it.
That distinction matters because Edge spans everything from a workstation beside a machine to a constrained embedded board. Teams already using Jetson-class hardware, robotics stacks, or simulation pipelines now have a new Cosmos slot to watch. A smaller model that can be adapted on a workstation would also broaden access beyond organizations with large training clusters. The real change arrives when NVIDIA's published weights and model card reveal the compute envelope and supported media. For now, Cosmos 3 Edge shows where NVIDIA wants physical AI to go: less round-trip dependence, lower latency, and world model capability closer to the machinery taking action. The European Commission published guidance on July 20 for transparency obligations taking effect August 2, 2026 under the EU AI Act. Providers have two direct duties. Systems must tell people when they're interacting with AI rather than a human, and generated or manipulated content must carry machine-readable markings that detection systems can use to identify its origin.
That's concrete and broader than slapping AI powered on a landing page. Interactive products need disclosure where the interaction occurs. Generated media needs embedded provenance information intended to survive downstream handling. The Commission's guidelines cover both marking and labeling, accompanied by a code of practice for AI-generated content and a question-and-answer document about Article 50.
Businesses deploying systems have separate obligations. They must notify people when content is a deepfake, when AI-generated material concerns a matter of public interest and lacks human review or editorial responsibility, and when emotion recognition or biometric categorization is being used. Emotion recognition means inferring feelings from faces, voices, or body language. Biometric categorization means sorting people through biological characteristics, including sensitive traits. Those uses create stakes well beyond whether a chatbot introduced itself correctly.
And here's where the earlier local agent enthusiasm meets law. Running something locally doesn't erase duties when a product reaches people in the EU. Visible disclosure and machine-readable provenance become part of the shipped behavior, while emotion or biometric systems need explicit notice before operating. The unresolved question is whether providers and deployers converge on technical markings that remain detectable after cropping, transcoding, editing, or reposting. Enforcement after August 2nd will show how aggressively authorities interpret those obligations. But "we'll add transparency later" is no longer a harmless product delay. The rules attach disclosure to the interaction and provenance to the output itself. Coding agents fill context with file reads, searches, and tool output until useful information gets buried or discarded. SWE Pruner Pro argues the agent already carries a relevance signal inside its own internal activations, the numerical state created while processing that material.
Instead of attaching a separate classifier to score every chunk, the researchers train a small decision layer over those internal representations. It chooses what to preserve and what to drop within the agent loop. That's neat, less external machinery, and potentially lower overhead during long repository work.
The result could help multi-file refactors and extended debugging sessions reach completion before the context window collapses. It also pairs naturally with code-based memory-mcp. One system stores durable repository structure outside the prompt, while the other keeps the active prompt from becoming a junk drawer. Integration into open coding agents will show whether the approach delivers those savings beyond the research setting.
A new paper reframes retrieval-augmented generation, or RAG, as nearest neighbor matching, pairing a new case with similar historical cases, an idea used in statistics since the 1980s. The authors formalize that connection and derive a bound on regret, meaning a limit on how much worse the resulting decision can be than the best available decision under their assumptions.
That's more interesting than another retrieval score. When a model uses retrieved examples to choose an action, such as a treatment, offer, or fraud decision, the index behaves like a matching engine, not merely a document search box.
The guarantee is mathematical, not automatic proof that every production RAG system is safe or optimal. Real value depends on whether the data, similarity function, and downstream predictor satisfy the assumptions. Still, the paper gives action-oriented RAG a clearer statistical foundation and a different way to judge retrieval quality.
Microsoft's MCP for Beginners curriculum received an update on July 20th, and this is underhyped infrastructure for people learning how agents connect to real tools. The open-source material provides runnable examples in .NET, Java, TypeScript, JavaScript, Rust, and Python. 6 languages, 1 set of concepts, and far less translating from somebody else's favorite stack.
Model Context Protocol gives a model host a standardized way to call tools and data sources. The curriculum covers both sides, the client, where the model and its host initiate requests, and the server, where a tool or service exposes structured capabilities. It moves through modular design, scaling patterns, and security considerations, the parts that matter once a toy weather tool becomes access to a database, code runner, or internal service.
The cross-language structure is the clever bit. A Rust backend engineer and a TypeScript application developer can study the same interaction in idiomatic code rather than debating which software kit offers the canonical example. Beginners get a guided path, experienced developers get working scaffolding they can adapt. The repository has accumulated 16,802 stars, which is a strong sign that the material has found an audience.
It remains maintained documentation rather than a tagged product release, with a fresh commit on July 20th. That's appropriate for a curriculum, where examples need to evolve as protocol libraries and security practices change. And it helps the tools we've already mentioned, Unity, Codebase Memory, Code, and the frameworks coming later all become more useful when developers understand the contract connecting agent and server. The next meaningful expansion would be additional languages or more advanced patterns for authorization, deployment, and multi-server systems, not more introductory hype around the acronym. Sentry's CodeBuild-MCP has crossed 6,100 GitHub stars. It gives AI agents structured tools for iOS and macOS projects through both a model context protocol server and a command line interface. The project shipped 0.262 on June 2nd and received another repository push on July 21st.
iOS is exactly where this bridge earns its keep. Xcode's command line behavior can be quirky, build output is noisy, and project files don't reward reckless editing. A general coding model may know the command it wants to run, but that isn't the same as having a reliable, structured interface for invoking an operation and interpreting what came back.
CodeBuild-MCP supplies that interface. An agent can drive project operations and receive structured results rather than hallucinating commands or asking a person to shuttle terminal output into chat. That supports tighter loops around code changes, builds, and Apple platform workflows. Hands-off still shouldn't be confused with consequence-free, especially around signing, project configuration, and destructive actions, but the agent now has a purpose-built toolbelt instead of a pile of copied text.
6,000 stars for an Apple development bridge is a strong signal that agent tooling is moving out of generic shell wrappers and into domain-specific surfaces. Sentry maintaining it also gives the project more credibility than an abandoned weekend experiment. The remaining friction sits in the host. Coding agents vary in how cleanly they accept third-party MCP servers and expose permissions. Once those integrations become routine, an iOS agent can move from suggesting code to operating the actual project loop. That's a meaningful maturity step, even if Xcode will probably find inventive new ways to complain. OpenAI's July 20th post on safety and alignment for long-horizon models is worrying in the useful way. The company says failures appeared during real deployments that wouldn't have surfaced in single-turn testing. A model that works for hours or days creates different problems from one that answers and stops.
OpenAI emphasizes iterative deployment, release systems into actual use, observe failures, improve safeguards, and repeat. The company credits that cycle with exposing both problems and possible fixes. This isn't a new model or a benchmark announcement. It's an argument that long-running behavior has to be understood across the full chain of actions, not inferred from isolated prompts.
Which makes sense. Small errors can accumulate. An agent can preserve a mistaken assumption, misread tool output, drift from the user's intent, or continue acting after the conditions around a task have changed. None of those requires a dramatic single bad answer. The harm can emerge from an ordinary-looking sequence that runs too long without correction. Have you ever watched an automation confidently continue after its first wrong turn? Give that loop more tools and more time, and the stakes rise quickly.
The uncomfortable part is that OpenAI observed deployment failures outside conventional evaluations, but the post doesn't give the industry a complete shared taxonomy. Its contribution is the operational framing. Long-horizon safety depends on seeing what the model did throughout a session and being able to intervene. That connects back to Hermes preserving delivery through gateway trouble and showing subagents live. Visibility isn't decoration when autonomous work stretches over time. Detailed postmortems from multiple labs and consistent names for recurring long-session failures would let teams compare behavior rather than treating every incident as unique. CarPlay Dev shipped Unity MCP 10.1 on July 13th, and the repository has passed 12,700 stars. It bridges MCP-capable assistants directly into the Unity editor, exposing operations for assets, scenes, scripts, and recurring editor work. Instead of generating instructions outside Unity, the assistant can call the editor's tools and make changes where the project lives.
This is the fun version of the Xcode story. A solo developer could ask an assistant to import textures, place them on scene objects, and create a C# script that changes sprites on a timer. A team could expose asset checks or repetitive scene setup through the same bridge. The developer stays in one conversational flow while the resulting changes appear inside the editor.
Direct access also makes permissions and observability important. Renaming an asset is harmless until references break. Editing a scene is convenient until the wrong objects move. Script changes can compile badly. The bridge doesn't guarantee the assistant makes good decisions. It gives those decisions a structured route into Unity, which is both the value and the reason people need to see what changed.
Still, 12,700 stars says game developers want more than code completion. They want assistants that can operate the editor, where a large share of game development actually happens. Players won't see MCP on screen, but developers may spend less time copying code, navigating panels, and repeating setup work. The bigger question is whether Unity itself eventually adopts native protocol support. If that happens, the community bridge could look like an early proof of a standard editor capability. For now, 10.1 turns chat into a control surface for scenes and assets, not just a place to ask how Unity works. Upsonic.77.3 gives Python developers a managed loop for autonomous agents, and the repository has attracted nearly 8,000 stars. The framework takes a goal, lets an agent choose steps and tools, executes those actions, and returns the result without requiring every team to hand-build planning and tool routing plumbing.
The tagged release arrived May 19th, followed by repository activity through June 18th. That's not brand new code, but it shows continued work after the release rather than a frozen package. The 0-point version number still signals a framework in active evolution. Nearly 8,000 stars signal interest, not a promise that interfaces won't change.
The natural uses are Python services where the workflow can't be fully predetermined, research assistants choosing sources, support triage selecting internal tools, or scheduled reports that gather information and decide how to assemble it. Because Upsonic is Python, it can sit inside a web service or run as a background worker alongside the libraries teams already use.
I like the time-saving pitch. I don't buy autonomous as a quality guarantee. A managed loop removes duplicate engineering, but the agent still depends on model judgment, tool definitions, permissions, and the framework's handling of errors. OpenAI's long horizon warning applies directly. The easier it becomes to launch an agent loop, the more important its behavior over many steps becomes. Upsonic's opportunity is to make that plumbing boring and dependable. Continued point releases would show whether the project is moving from an attractive prototyping toolkit toward something teams can confidently build around. Unity MCP leads the radar at 12,709 stars. Its first tracked appearance follows the 10.1 release on July 13th, the same date as the latest noted repository update. The bridge exposes Unity assets, scenes, and scripts as structured agent tools. Its integration angle is direct. MCP-capable agents, including terminal coding agents, can operate the editor instead of relying on stubbed interfaces or copied instructions.
MCP use has 10,337 stars and shipped 0.343 on July 8, with another repository update on July 20th. It provides full-stack scaffolding for MCP applications targeting ChatGPT and Claude, plus servers for AI agents. The headline feature is a unified client-and-server framework with tool routing and shared schema validation, so an AgentStack can connect structured requests and responses without writing every compatibility layer from scratch.
Lastmile Ari's MCP agent sits at 8,459 stars. Its latest tagged release is 0.0021 from May 2025, while the repository was updated in January 2026. It layers reusable sequential, parallel, and router workflows over MCP servers. that lets Hermes or Claude-style agents compose multi-step pipelines without bespoke orchestration glue. The age of the tag makes current activity worth distinguishing from momentum, but the workflow primitives remain a clear integration idea.
Model progress landed more in compression, edge deployment, evaluation, and domain adaptation than in a new general-purpose provider model. Ternary Bonsai compressed a 27B system for local hardware, while Cosmos 3 Edge pushed a world model family toward constrained physical AI environments.
Inkling is a multimodal open-weights model from thinking machines that handles text, images, and audio in one conversational interface. It uses a mixture of experts design, where only part of the network activates for each token, reducing active compute relative to using every parameter every time. The weights ship as Sapphire tensors under the permissive Apache 2 license, with published evaluation results.
That's an appealing self-hosting combination: multiple media types, open weights, and lower active parameter use. Teams needing private vision, audio, and chat could put one model behind an agent instead of sending each medium to a separate cloud service. It fits common local inference tooling, and the referenced multimodal use targets a 24GB GPU. Latency and quality will depend on the checkpoint and workload, but Inkling looks unusually practical on paper. AppCipher's awesome MCP servers, with 5,704 stars, catalogs protocol servers by transport, local process connections versus streamable web connections, and capability tags. That's useful for compatibility discovery, not merely collecting links. The repository doesn't have a tagged release, but its organized index helps people distinguish servers that fit a particular runtime from ones that merely use the MCP label.
The OpenAgent project's OpenAgent has 5,426 stars and a .831 release from July 8. It combines retrieval, coding, browser control, and computer use behind one model-driven state machine, showing how several agent modes can share a single execution loop. That's ambitious, maybe uncomfortably so, but it reflects the push toward assistants that move between information gathering and direct action.
And don't miss Nambanks's 5IR, a cross-platform desktop AI assistant and MCP client with 5,283 stars. Its latest listed release is .15.4. It supports major model providers, local knowledge, and tools supplied through MCP servers. The technical hook is on-device retrieval. 5IR checks a local vector store, an index of numerical document representations, before sending context into the model call. That gives desktop users persistent local knowledge while preserving the option to use external models. It matters because local memory and cloud intelligence don't have to be all-or-nothing choices.
Faster startup makes Hermes easier to keep open, ternary weights make larger local models more plausible, persistent memory helps coding and work agents carry context forward, and WAD aims to bring database access and operational evidence into one view.
Cosmos moves physical AI toward edge hardware, while EU transparency rules attach disclosure to interactions and provenance to generated content. Context pruning, statistically grounded retrieval, and Microsoft's curriculum strengthen the software underneath agents.
CodeBuild MCP and Unity MCP put assistants inside specialist development tools. OpenAI's long horizon findings warn that hours of action reveal failures a single answer won't. Upsonic makes those loops easier to build, which makes that warning more relevant, not less.
For source details and further reading, look at the show notes at tobeyonfitnesstech.com. Thanks for listening to AgentStack Daily. We'll be back soon.